Hey guys, welcome back to where we're going to finish talking about the general form of our exponential functions using word problems. We're picking up here with example 8 where it says write a story that could be modeled by y equals 150 times 2 to the x. So basically all we want to do is come up with a scenario that can relate and possibly be the example for this. So let's say we need to make sure that we understand what our pieces are. So the 150, remember, that is our A value. That's the initial value and what we start with. So it's our A, 150. So we need to come up with something that's going to start with a value of 150. It can be money, it can be a population, it can be whatever we want it to be as long as we start with 150. The 2 here, this is telling us that we have an exponential growth function. That's our B value. Okay, so our B value is 2. So that's telling us how it's growing. So that means we need to be using a word that represents how it's growing by 2. So every single time we need to refer to this, that it's, sorry guys, I'm having trouble writing, that it doubles. Okay, so we need to be using the word doubles in our work. All right, so I'm going to give you my example that I came up with. So let's look at what I've got. I put, if I bought a gold ring for $150, the value of the ring, sorry, I bought a gold ring for $150. The value of the ring doubles each year. Okay, so that is my situation or my scenario. So let's kind of just double check and make sure that it does hold up to what we said. We said that we needed to use 150 as the starting value, which I did, and I used mine in money. And I said, how did it grow? Well, it's going to double each year. So my time frame that we're looking at is years, and we know every single time it's going to double. With that, I then went a little bit farther and I put a problem and I said, well, how much will my ring be worth in 3 years? So if we wanted to solve this, all we would be doing is saying, what is this function when we plug a 3 in for the x? So that could look just like this, where we said we would plug a 3 into the x, which is our exponent right here, and then just let our calculator help us to do the math, and we would get that my ring would be worth $1,200 after 3 years. Okay, so you can either write down that example of mine, or you could write down your own example, whichever way you would like to do that. All right, so let's go and look at some practice. I'm going to work the first one with you, and then I'm going to have you guys work some of them out and check your answers with mine. So the first one says, identify the growth or decay factor for each exponential function, then circle whether the table represents an exponential growth or an exponential decay. So remember back in our practice that we did, we said that the easiest way to determine what our growth or decay factor is to take this second term, so the second value, which here we have 18, and we're going to divide it by the first. So I'll just come right over here and I'll say, okay, 18 divided by 6. So this one's actually easy. 18 divided by 6 is a 3. So that means that our growth or decay factor is going to be a 3. This is our B value. Okay, so our B value is a 3. So remember our rules said if B is greater than 1, it was going to be an exponential growth function. So here we know that we have a growth function for the table. So go ahead, take a second, pause the video and do B and C, and then come back and check your work. All right, so you should have that B has a B value of 1/4, and that's an exponential decay, And then the C has a B value of 1.1, and it's an exponential growth. All right, so now we're going to move on and we're going to talk about Tessa. It says Tessa is sick. The doctor says she has a bacterial virus that has 2,500 strands. She is put on an antibacterial medicine that decreases the number of strands by half each day. First, we want to write an exponential function that represents the situation. So we need to identify some important pieces. So this 2,500, this is how many strands she starts with. So this is going to be our initial value, that A value. Okay, then we already know it says that it's going to decrease. So that should kind of give us an idea that we're going to have an exponential decay function here. Our numbers, our strands should be getting smaller and smaller every single time. Well, how much are they going to get smaller by? Well, by half each day. So this half, this is going to be our B, our growth or decay factor. So it's going to be a decay factor of 1/2. If you want to use 0.5, then that's fine as well. So from here, we can write our equation. Y equals 2,500 times 1/2, and we're going to put X. X is representing each day here. It says per day, each day, and the Y is just going to be the total. So now that we have that, we can answer the question, how many strands of the virus does Tessa still have after 5 days on the medicine? So now we have to figure out, where's this 5 days going? Well, remember, we said it's decreasing by half each day. So that means our X is representing the day. So what we're going to do is we're going to take 5 and put it in place of the X in the equation to represent days. So Y equals 2,500 times 1/2 to the 5th power. So all we're going to do is type it into our calculator. So I'm going to do that right now. 2,500 times 1/2 raised to the 5. And we are going to get that Y equals 78.125. And I'm not a doctor, so I don't really know if you can have a partial strand of virus or not. So I'm going to leave that as my answer for now. Now, if we were counting things like animals or people or like population, things that can't be a part of a person, then we would want to make sure that we round appropriately. So like in this case, if this was talking about something that could not be a partial, then we would actually need to round down because we don't have that whole person or that whole animal. So, but here in this case, we're just fine with leaving the decimal. Okay, so now we're going to look at our last question. So it's kind of a little bit long. It says, complete the following for the situation. I'm going to help you get started on this one, and then you're going to finish it and check it on your own. So it says, find the exponential function that models the situation. So it says a population of squirrels starts with, that's important, starts with 2 squirrels, and it triples every week. So with those 2 pieces, we know that the A is always our initial value. What we start with? Well, they're starting with 2 squirrels. And our B is going to be our growth or decay factor. So how fast is it growing or how fast is it decaying? So here it says it triples. So triples means 3. So now we can write our equation. So remember, f of x is another way to say y. So if it's already written there, we don't write it again. But I am going to put the 2 for the A, then the 3, and then we're just going to put an x because this is going to be per week. So our x's are going to represent per week. Okay, from here we can fill in the population. So at the beginning, at week 0, we had a population of 2. Every single time it's going to triple. So we're going to take 2 and we're going to triple that. So that means we don't just have 2, we have 2 3 times. So that means we have 6. Okay, so what I want you to do is go ahead and keep tripling to get your table. Then you're going to label your X and Y axis, plot your graph, answer how many squirrels in 10 weeks, write your answer in function notation, and do the domain and range. So pause the video here, do those things, and come back and check your answer. All right, so this is what you should have. Your table should be 2, 6, 18, 54, 162, 486. When you plug in a 10 into your equation for the X, you get 118,098 squirrels. So in function notation, that would give us f of 10 equals 118,098. The domain of your graph, so when you graph this, you've got weeks. On the x-axis, I counted by ones but wrote every other one. And then my y-axis is my population, and I counted each line by tens, but I only labeled every other one. Pardon my graph, it's a little warbly and crooked. But from here, we can say that our domain is from 0 to infinity. Okay, bracket at the 0 because that's where we start on our weeks. We start at week 0. We can't go any lower than that. And then for our range, it's going to be 2 to infinity because the smallest y value that we have, our population value, starts with a 2 and then keeps getting larger and growing and growing and growing. All right, if you have any questions, please reach out. You have a good day.